This lesson is find the characteristic polynomial and the eigenvalue of the matrix. Here is a matrix. This is a 3 by 3. Here is A minus lambda times I. Again, since this is a 3 by 3, we will use a 3 by 3 identity, which is 1 0 0 0 1 0 0 0 1. I times that identity is just this, okay? And then A subtract this. Again, this is a 3 by 3, so we will use the identity matrix 3 by 3. So 1 0 0 0 1 0 0 0 1. And when lambda multiply I, you just get this only, okay? Where the diagonal is just all 1, so that's where all the lambda is, and the rest is just 0. After that, we just subtract across, so 1 subtract lambda, 0 subtract 0, negative 1 subtract 0, 2 subtract 0, 3 subtract 0, 3 subtract lambda, which is this, negative 1 subtract 0 is this, 0 subtract 0 is here, 6 subtract 0 is here, and then 0 subtract lambda will be just lambda. Okay, now use this matrix and find the determinant of it. Okay, use this matrix and find the determinant of it. And we're going to use cofactors. And if you remember cofactors, okay, this row block this row. Okay, so I'm going to use this term here. So this row and this row is blocked out. One more time, I'm using the first term here. So 1 minus lambda. This row and this column is blocked out. Row, column is blocked out. All I have left is just this 3 negative lambda 6, 3 negative lambda 6, negative 1 negative lambda. Next is this term. Since this is a plus, next will be minus. So minus 0. This row, this column is blocked. This row and this column is blocked. So I just have 2 0. And then negative 1 negative lambda is this. So now it's minus. So next will be plus. So plus minus plus. So the next one will be negative 1, which is here. This row, this column is blocked. This row and this column is blocked. So I just have 2 0, 3 negative lambda, and 6. Okay, so one more time. I use this term here. This row, this column is blocked. I just have this only here. This is a plus, so the next should be minus 0. This row, this column is blocked, so I just have 2 0 1 negative 1 negative lambda, and then after negative it would be positive, so negative 1, which is here. This row, this column is blocked, so 2 3 negative lambda here, 0 6 here. After that, you just do the 2 by 2 matrix. So this times this, so this times this is here, minus negative 1 times 6, which is here. Okay, 0 is just 0, so 0 times anything is just 0. Bring down the negative 1, so 2 times 6 minus 0 times that is here. Okay, so one more time, 3 lambda, 3 minus lambda times negative lambda, which is here, minus 1 negative 1 times 6, which is here. 0 times anything is just 0. Bring down the negative 1. 2 times 6 is here, and 0 times 3 negative lambda is here. After that, simplify a little bit more. So bring down this to here. So 3 times negative lambda is negative lambda squared. 3 times negative lambda will be negative 3 lambda here. And then negative lambda will be positive lambda squared. And this gives me negative 6, another negative positive 6. So when you multiply and simplify, make sure you put it in highest order power down to the lowest. So 3 times negative lambda would be here. Negative lambda will be positive lambda squared. Negative 6 plus 6. 0 is just 0, so bring down this negative 1. 2 times 6 is 12, which is here, and 0 times anything is just 0. Multiply it again and then simplify again. So 1 times lambda squared, 1 times negative 3 lambda, 1 times 6 is right here, positive 6. And then negative lambda times lambda squared is lambda cubed, so negative lambda cubed. Negative times negative lambda times negative 3 lambda, which is positive lambda squared. And then negative lambda times 6 will be negative 6 lambda. And then don't forget this negative, so it becomes negative 12. Now put this in highest order from biggest to smallest. So I only have 1 lambda cube, so that goes first. Here I have lambda square, which is 1. 3 lambda square. This is positive, so 1 plus 3 gives me this 4. Next, just lambda only, so negative 3. And over here, negative 6, so negative 3 plus negative 6, negative 9 lambda. And then 6 subtract 12 gives me negative 6. Okay, so this right here is called the characteristic polynomial. However, this polynomial cannot be factored. Okay, so and it takes a very long time to get this answer. So for now, we'll just jump to the answer. One more time. This polynomial is not factorable. So we have to do a lot of work just to get this answer. So we're just going to skip that process and go straight to the answer. So the first eigenvalue is negative 0.52698. And this is an irrational value. So this decimal will keep on going. Next, the other two eigenvalue of lambda is imaginary, so we'll leave that alone too. So for now, just accept these answers because the process of getting from here to here is very, very lengthy and complicated. So we'll just skip that process and just go straight to the answer. So the first answer will be this. And the other two answer is imaginary. So these three answers are the eigenvalues. Okay, so these three answer is the eigenvalue. This is the characteristic polynomial. And this is the solution to finding the eigenvalue. Okay. And the eigenvalue here is not easy because this polynomial is not factorable. So we'll just skip that process and go straight to the answer. Again, this is the characteristic polynomial, and these three is the solution of that eigenvalue. Okay.